Hello, I'm just here to review the answers to quiz number 5. So, part A for number 1 is asking us to find the area to the right of the z-value 2.35. Now, to do this, we draw the standard normal distribution. Remember, at the center is the mean 0, and 2.35 is on the right side, so we have to find this tail area. To look up that tail area, we need to turn to table E. Let me get this situated here. And we're going to go to table E. We go to the second page of table E. And so we're looking for 2.35. So here's 2.3. The first two digits are in this first column, and then we have to go across until we're under 0.05. So this is 0, 1, 2, 3, 4, 5. 0.9906. Now remember, whenever we look up an area in table E, it's always the area to the left. But we desire the area to the right, so we have to take 1 minus 0.9906 to get our answer, 0.0094. Now for part B, we're looking for the area to the left of 1.26. So once again, we turn to table E, we look for 1.2, 0, 1, 2, 3, 4, 5, 6, 0.8962, and that's going to be the answer since it's an area to the left. So whenever we desire an area to the left, we just have to look it up in table E. Now when we need to find the area between two z-values, we have to look up both areas and then subtract the smaller from larger. I always start on the right side. I look up the area for 0.24. So for 0.24, we got 0.2, 0, 1, 2, 3, 4, 0.5948. And then I look up the area for negative 8.99. Remember, those are always areas to the left. Now, if we have a value like negative 8.99, we have to use the information at the bottom of the chart. It says for any z-values less than negative 3.49, we use the area 0.0001. So we subtract those two areas, and our answer is 0.5947. If we're looking for the area to the right of negative 6.89, using the same information, remember, if there's a z-value that's less than negative 3.49, the area is 0.0001. But we want the area to the right, so you take 1 minus that area to get an answer of 0.9999. Okay, number 2, we're trying to find the area. Actually, we're trying to find this missing z-value. We're given a tail area to the right of it, 0.0401. But in order to find this z-value in table E, we need to find this area here. And to calculate the area, we take 1 minus 0.0401, which is 0.9599. Thus, we look up the area closest to 0.9599 in the area section. So if we look in the chart, here's 0.94. Here it is right here, 0.9599. Look to the left, it's 1.7. Look up, 5. So the missing z-value is 1.75. Number 3, we're trying to find a probability. So we're applying the normal distribution. We draw the normal distribution we put down the mean as 24.5. We have our value 29. We want the area to the right of it. So in order to find this area, we have to convert to z-values. So we're going to take 29 minus the mean, 24.5, divided by 3.45, which is the standard deviation. That's going to give us the z-value 1.3. We look up 1.3 in our table. Here's 1.3.9032. That's the area to the left, but we want the area to the right. So 1 minus 0.9032 is 0.0968, which is the answer. Now for number 4, we're using cutoff scores here. It says the top 8% in a right tail area under the normal distribution. So we were given a top 8%. We have to get the area to the left. So 1 minus 0.08 is 0.92. Remember, the mean is 580, standard deviation 96. So using the area closest to 0.92, we're going to find the z-value. So let's look for the area closest to 0.92. Here's 0.9265. We want a value that's closest to it. And I believe this is as close as we're going to get, 0.9207. So that's 1.41. That's the z-value. So our process is we have to draw the normal distribution, shade in the area, use the areas to get the z-value. Once we have the z-value, we calculate the cutoff score. X is the mu, 580, plus the z-value, 1.41 times standard deviation, 96, which rounds to 715. And for number 5, this is a problem involving the central limit theorem. So we have our mean is 20, the sample mean is 23. We want this area greater than 23. Standard deviation is 4.3 and is 50. So we have to calculate first the z-score. And let's go ahead and do this on the calculator just to demonstrate how it's computed. So I like to use the parentheses. So we have 23 minus 20, close the parentheses, divided by, now we use parentheses again, and we type in our denominator, which is 4.3, divided by the square root of, I believe it was 50. Let's check it real quick. And then, oops, let me go back. Sorry, let me retype that again. So square root of 50. Let's escape out of there and then close the parentheses. Hit enter. And we get 4.93 as the z-value. Once we have the z-value, we then look it up in our table. And we can see that 4.93 is greater than 3.49. So the area to the left is 0.9999. But we want the area to the right, so we have to take 1 minus that, and the probability is 0.0001. Thanks for watching the video.